Hello learners, Mr. G here, and this is going to be a short video about Newton's third law of motion. Okay, in previous video we just apply the first and the second law to different situations. We are going to be doing now and speaking about Newton's third law of motion. Okay, so let's start by studying Newton's law of motion. What does this Newton's third law of motion state? When an object A exerts a force on object B, then object B exerts the force on object A equal in magnitude but in opposite direction. So what you have to note here about this definition. First of all, you have two objects. You have object A and you have object B. So the interaction between objects always happen in pair. Always they happen in pair. Now, this is just staying the law. When an object A exerts the force on object B, then object B exerts the force on object A of equal magnitude but in the opposite direction. Okay? So this, if we write the formula, we say that the force of object A on B will be equal to the force from B on A, but they are in opposite direction. So that is why that is the negative. So this is the expression for Newton's third law. Okay, now let's quickly have a look at certain points in this work. Okay, now there are many properties about Newton's third law, about this action-reaction pair. This law is called law of action-reaction. Now there's many different properties of action-reaction. I am not going to go through all of them. There is certain ones that I think they are very important, and the first very important to me is that the forces or the interactions act on different objects. The interaction of forces act on different objects. That is the first important thing. The forces or the interactions act on different objects. For example, if a block is resting on the table, let's just do the drawing of the table, and I'll be back in 1 minute. Alright, for example, we have a book on the table. Obvious, the table is on the ground and the ground is part of the earth's surface. So we have here different objects. We have book, we have a table, we have the ground, and we have the earth. So before you speak or you select the action-reaction pair, the forces that are interacting, you have to identify what objects are the ones involved in the interaction you want to identify. For example, here we have all the objects are acting to each other. All of them are in contact one with the other. Now, let's say the work that we are supposed to select, or the two objects are going to be the block, and we're going to select the table. So obviously the part of the table that is in touch with the block is this side there. So the rest of the objects, the ground, the earth, the air, whatever is left there is not part of our interaction. So the two objects that we are working and dealing are the table, and we are dealing with the block. Okay, we're dealing with the table and we're dealing with the block. So those are the two objects involved in this action-reaction pair. The rest of the objects are not part of the work. Okay, so if we represent here the forces acting, we need to know that the table is pushing upward the block. That force is the force we'll call, in actual fact, normal force. This is called normal force, or you can call them force from table on block. Okay? But that in actual fact is the normal force that you know. Is the force from the surface of the object that is on the surface. Okay? And it's perpendicular. Now, along the same line, because that is another property of action-reaction pair. They act along the same line. So that is another property which I'm going to write here at the bottom. The forces act along the same line. Okay, they're acting along the same line. So that means that the reaction force to this force from the surface must be along the same line to which this force is acting. But now they're acting on different objects. Remember, they're acting on different objects. The objects are block and table. So the table is acting on the block with a force that we call normal force from table on the block. And the block is going to be acting on the table with a force that is what we can actually call apparent weight. That is the force from block on table. Alright, that is the force from block on table. This here is what we call a action-reaction pair. These two forces here are the action-reaction pair. And we say that normal force is equal to minus the force from block on table. This is an action-reaction pair. This force here is what we called apparent weight. Is the reaction to the normal force. Alright, so in this example we have many objects, but the first thing you need to know is what objects are part of the example. Okay, so let's see the same example now, but let's take another action-reaction pair. Alright, the same situation, but now the objects are going to be the block. The block is going to be the first object, and the second object is going to be the earth, for example. So the table is in between, but is not part of our system. It's not what we selected. All right, so what will the action-reaction pair be now? What is the earth doing to the book? Is pulling it down with a force that we actually call weight. This weight is not other thing than the force from the earth on the book. All right, and the book is pulling up the earth with a force that is equal in magnitude. That must be from the center of the earth. We cannot do the drawing. This is the force. This is force from book on earth. Alright, this is the force from the book on the earth. Now, these are the action-reaction pair in this different situation. That's going to be this force and this force are the action-reaction pair. So we can say that the weight on the book is equal to minus the force from the book on earth. This is what we call an action-reaction pair. They are equal in magnitude but opposite in direction. So I hope this is clear in terms of action-reaction pair. It's not that difficult. Let's see one last example. And we'll take it there. We'll stop there. Okay. So let's say this situation in which a force has been applied to an object A, but object A is together with an object B. So these objects are going to move to the right. Okay. They move into the right. So let's see. There are many objects. There is the table. There's a table here. There is block A, there is block B, there is a force applying on object A. So before you identify action-reaction pair, you must select what objects are going to be the system we are going to deal with. So for example, here we are going to work with the object A and object B. So those are the ones. What you need to know, object A is pushing forward object B. So on object B will be the force from A. This force here is going to be called force from A on B. The rest of the system, the rest of whatever is involved there is not part of our study. The table is not part, the applied force is not part. And object B at the same time is pushing object A in the opposite direction. This is force from B on A. What you need to know, force from B on A must be equal in magnitude to force A on B, but in opposite direction. This is the action-reaction pair. So my word is, you always have to identify what objects are part of the system. Okay? So there is different system, there is different pair, there is many pairs in this simple picture. For example, the table is acting on B, is pushing B up, B is pushing the table down. The table is pushing A up, A is pushing the table down, but you always were in pair. So whenever you select the pair, then the rest of the forces are not part of our study. I hope this is clear. It is a little bit confused sometimes. It's not a big issue. I hope it helped. Thank you for watching. Good luck, and please let me know if it can make another video or you need more help. Okay? Thanks a lot.